Hello and welcome back. In today's video, I'm introducing you to the Foundation Toolkit and use it to overclock the Intel Core i9-14900K on the GIGABYTE Z790 AORUS Master X motherboard. The main purpose of the video is to introduce you to the Foundation Toolkit and show you how you can use it to overclock your Raptor Lake Refresh processor. Alright, let's jump straight in. Let's immediately start with the buzzwords. Foundation Toolkit is a next-generation cloud-based CPU silicon customization software. It was co-developed by Matthias from Benchmate and myself. While we have big hopes and dreams for the application, currently the Foundation Toolkit exclusively integrates the Intel Extreme Tuning utility. The Foundation Toolkit enables precise CPU performance tuning and caters to the Intel K-SKU CPU user crowd. The Foundation Toolkit should be freely available for anyone to use at the moment. You can just access the website. Do note that the amount of functions is still pretty limited. There are 4 primary functionalities of the toolkit available: monitoring the system, simple overclocking with Intel Speed Optimizer, advanced overclocking with the Foundation OC knobs, and running the supermassive workload. On the monitor page, you can find many system information charts detailing the current state of the P-core, E-core, and general CPU metrics. You can monitor the current operating frequency, voltage, temperature, and load for P-core and E-core. You can also monitor the CPU power consumption and the memory frequency. Let me get a little bit technical about each of these monitoring items. P-core load returns the percentage of the P-core resources currently in use. P-core frequency returns the maximum frequency across all P-cores. P-core voltage returns the maximum voltage across all P-cores, and P-core temperature returns the max temperature across all the P-cores. E-core load returns the percentage of the E-core resources currently in use. E-core frequency returns the maximum frequency across all E-cores. E-core voltage returns the maximum voltage across all E-cores, and E-core temperature returns the maximum temperature across all E-cores. CPU power returns the CPU package power, which includes the power used by all parts inside your CPU. Memory frequency returns the memory frequency in megatransfers per second, for example 8000 for DDR5 8000. Note that the reported voltage is the CPU's VID voltage request, not the measured voltage at the CPU die. The actual core voltage may be impacted by various offsets and load lines. ISO stands for Intel Speed Optimizer, a performance-enhancing technology embedded in the Intel Extreme Tuning utility software. Its primary purpose is to simplify overclocking. If your processor supports ISO, you can enable higher performance by clicking a single button. At the moment of recording, the 14900K did not support ISO yet, but I did set up a 13900K system to show you how it works. For your convenience, we also integrated a monitoring chart and a workload. The monitoring chart lets you check the current P-core and E-core frequency and temperature. The workload allows you to check the performance before and after enabling ISO. Note that you cannot do any manual tuning when ISO is enabled. The tune page exposes the essential overclocking knobs to fine-tune the performance of your Intel processor. Please be aware though that these knobs are for advanced users, so please proceed carefully. There's a warning at the top of the page for a reason. You can adjust the CPU P-core and E-core frequency, set a CPU core global adaptive voltage, tune the Turbo Boost 2.0 power limit, and add an AVX2 ratio offset. I will explain the technical side of these overclocking knobs when we get to overclocking the Intel Core i9-14900K processor in a minute or so. On the workload page, you can find links to the 4 variants of the supermassive workload: SSE2+, AVX, AVX2, and AVX512. Clicking on the links will bring you to the workload specific page. The supermassive workload uses gravitational ray tracing to render a black hole according to Einstein's general relativity theory. The workload extensively uses optimized tensor math to calculate each pixel as fast as possible while utilizing all CPU cores. On each page, you'll find the P-core, E-core, and CPU information, a button to start the workload, and a results chart to keep track of your process. Now let's dig into how you can use the Foundation Toolkit to overclock your processor. First, let's have a closer look at each of the overclocking knobs available on the Tune page. The Tune page provides 8 overclocking tools. Let me get a little bit technical about each of these knobs. P-core ratio sets the all-core active P-core turbo boost ratio, as well as each P-cores per core ratio limit if it's below the all-core ratio. E-core ratio sets the 1 active to 16 active E-core turbo ratio, and each E-cores group per core ratio limit. Effectively, you can think of this as an all-core fixed E-core ratio. Core voltage mode lets you switch between adaptive or static voltage for the CPU cores. It's set to adaptive by default, and you cannot change it. However, configuring a manual core voltage unlocks core voltage mode. After a page refresh, you can select between adaptive or static voltage mode. Core voltage sets the global CPU core voltage. It also sets each P-core and E-core per core voltage. Note that adaptive and static voltage modes function very differently. We'll dig deeper into this topic when we start manual overclocking. Sustained power limit sets the Turbo Boost 2.0 PL1, which is the parameter that governs the sustained power consumption limit. Temporary power limit sets the Turbo Boost 2.0 PL2, which is the parameter that governs the temporary power consumption limit. Core current limit sets the Turbo Boost 2.0 ICC max, which is the parameter that governs the sustained core current limit. AVX2 offset sets the AVX2 ratio offset. The offset is applied to each core's per core ratio limit and activates when there's an AVX2 workload. On processors that support AVX512 or AMX offset, adjusting the AVX2 offset will also change those two offsets. On the Tune page, you can also find system information in dynamic text and an actual monitoring chart. Alright, let's get started with the overclocking. First, let's have a look at the default specifications of the Intel Core i9-14900K processor. The default Turbo Boost 2.0 ratio configuration allows only 2 of the 8 P-cores to boost to 6 GHz. These are the so-called favored cores. The other cores are limited to a maximum of 5.7 GHz. Furthermore, the 2 favored cores can only boost up to 6 GHz when up to 2 P-cores are active. When more than 2 P-cores are active, their frequency is also limited to 5.7 GHz. Similarly, the E-cores have their own ratio limits. Each of the 4 E-core clusters, containing 4 E-cores each, is limited to 4.4 GHz. They will boost to 4.4 GHz in any scenario. The default Turbo Boost 2.0 power limit is 253 Watt for both the sustained and temporary power limit. For educational purposes, I also extracted the VF curve for this CPU's P-core and E-core. The VF curve is a factory-fused voltage frequency curve per core that describes the relationship between a certain ratio and the voltage required to run that ratio stably. In my case, the CPU has a P-core VF curve that goes from 8x at 0.715 volt to 60x at 1.465 volt. The E-core VF curve goes from 8x at 0.715 volt to 44x at 1.265 volt. Next, we must cover the adaptive and static CPU voltage modes. Override mode specifies a single fixed voltage across all ratios. It is mainly used for extreme overclocking, where stability at high frequencies is the only consideration. Adaptive mode is the standard mode of operation, where the CPU relies on the CPU VF curves to set the appropriate voltage. Both voltage modes can be controlled directly using the CPU registers, and that's exactly what we're doing when we're using the Foundation Toolkit. In adaptive mode, there are 4 important rules that govern the CPU voltage. 1. The adaptive voltage is mapped against the OC ratio. The OC ratio is the highest ratio configured for the CPU. When you leave everything at default, the default maximum turbo ratio determines the OC ratio. In the case of the 14900K, that ratio would be 60x. When you manually overclock, the OC ratio is the highest ratio you configure across all the various settings and options. 2. The voltage set for a given ratio N must be higher than or equal to that's set for a ratio n-1. Suppose our 14900K runs 60x at 1.45 volt. In that case, setting the adaptive voltage mapped to 60x lower than 1.45 volt is pointless. 60x will always run at 1.45 volt or higher. 3. The adaptive voltage configured for any ratio below the maximum default ratio will be ignored. Take the same example of the 14900K, specified to run 60x at 1.45 volt. If you try to configure all cores to 57x and set 1.2 volt, the CPU will ignore this because it has a factory-fused target voltage for all ratios up to 60x and will use this voltage. 4. For ratios between the OC ratio and the next highest factory-fused VF point, the voltage is interpolated between the set adaptive and factory-fused voltage. Returning to our example of our 14900K specified to run 60x at 1.45 volt, let's say we manually configure the OC ratio to be 65x at 1.55 volt. The target voltage for ratios 61x, 62x, 63x, and 64x is now interpolated between 1.45 volt and 1.55 volt. The final important information is that the CPU P-cores, E-cores, and ring share the same VCC core voltage rail. Effectively, it means that when the P-core runs 60x at 1.465 volt, it also runs the E-cores at 1.465 volt, regardless of its frequency or VF curve. Now that we know how the Core i9-14900K works, let's get to the overclocking. First, let's check the performance without any adjustments. The base performance with this Core i9-14900K is 13.71 seconds. Then, as a first modification, we maximize the Turbo Boost 2.0 power limits by setting the sustained and temporary power limit to 4095 watts and the core current limit to 512 amps. That effectively maxes out the allowed power usage for the CPU. The resulting workload performance is now 12.7 seconds. Then I try setting the P-core ratio to 60x and the E-core ratio to 44x. That overclocks 6 of the 8 P-cores from 5.7 GHz to 6 GHz and gets the frequency boost to 6 GHz even when all P-cores are active. However, we still rely on the CPU's factory-fused voltages. The resulting workload performance is now 12.3 seconds. Lastly, I try setting the P-core ratio to 61x, the E-core ratio to 46x, and the CPU global adaptive voltage to 1.475 volt. That overclocks all P-cores and E-cores and increases the operating voltage beyond the default specification. The resulting workload performance is now 12.12 seconds. Before we wrap up this video and you go off browsing to foundationtk.com to try the Foundation Toolkit, I need to tell you about a couple of important dependencies that you need to get right before you're able to get the Foundation Toolkit to run. Of course, you need hardware that supports overclocking. So you need an Intel CPU and motherboard with overclocking support enabled. Foundation Toolkit has no official hardware support list yet, but we tried it on 13 and 14th gen core processors. Unofficially, the Foundation Toolkit should support 8th to 14th gen core processor, 7th to 10th gen Core X processor, and the 1st and 4th gen Xeon processors. In addition to the hardware requirements, you also need BIOS support. 3 crucial settings need to be configured correctly. That includes disabling the overclocking lock, enabling the overclocking feature, and enabling the undervolt protection. Generally, these settings will be configured by default on motherboards that support overclocking. If not, you may need to go into the BIOS and set them manually. Lastly, some essential operating system settings must be configured appropriately to ensure you can install Foundation. Hyper-V must be disabled, core isolation memory integrity must also be disabled, and virtual machine platform must also be disabled. Anyway, that's it for today. I hope you enjoyed this video and maybe you're eager to run the Foundation Toolkit yourself. As per usual, I want to thank you for watching and the patrons for their support. I will have a written version of this video up on my blog if you want to sort of read through what I just explained in the video. And as per usual, if you have any questions or comments, drop them in the comment section below. And that's it. See you next time.